Good afternoon, Dr. Hatin Nibin Kasmin. Today our group will present the integrated hydrological analysis and flood risk assessment, specifically focusing on the weather region of Klang, Selangor. Before that, I would like to introduce my fellow team members, Susan Sausria Wong, Lo Shen Yun, Nur Alia Shahira, Muhammad Hafiz, and Chen Wan Nur Izyan. Hydrology is a scientific study of water's characteristics, distribution, and movement within the earth, soil, rocks, and atmosphere. It plays a crucial role in understanding and addressing challenges related to water management. Hydrological engineering is at the forefront, aiming to mitigate the impacts of natural calamities such as drought and floods. Our study delves into various applications, including urban drainage, water supply, wastewater treatment, river management, and coastal protection. To talk about the prevalence of flooding in Malaysia, one of the key elements in hydrology is rainfall. Rainfall, the total precipitation, is in the form of rain that falls on Earth's surface. It's a dynamic process influenced by air mass passing over warm bodies of water or moist land. The condensed water vapor eventually forms cloud, releasing as rain. A problem statement states that recent floods in areas like SMK Meru, Ahmad Kemuning, and others have been attributed to heavy rains, clogged drains, and the effect of climate change. Factors such as the accumulation of rubbish in drains as significant contributors to the flooding issues. To address this challenge, our study focused on the 3 rainfall stations, Bukan Meru, Taman Desa Kemuning, and Taman Seri Muda, and 1 water level station at Sungai Rasau in Taman Desa Kemuning. This location was chosen based on their association with frequent flooding in Klang. Our study set 4 clear objectives, which are to identify rainfall stations contributing to flooding issues in Klang, Selangor, to determine the amount of rainfall data for 3 selected rainfall stations and 1 water level station in Klang, Selangor, and to analyze the collected rainfall data. So for our methodology involves extracting 1 month of highest rainfall data from public flood information website. Additionally, we utilize Google Earth Pro to obtain terrain slopes and cross-section details of the nearest river to the selected stations.
Now we move on to chapter 4, result and analysis. To determine the mean area rainfall, we use arithmetic mean method. Sungai Rasau di Tunggul Keris, Sungai Rasau di Taman Desa Kemuning, Sungai Klang di Taman Seri Muda as our 3 station. The mean area rainfall for Sungai Rasau di Tunggul Keris is 5.286 and Sungai Rasau di Taman Desa Kemuning is 8.143. And the last one, Sungai Klang di Taman Seri Muda is 7.286. The mean value of these 3 stations is 6.905. The second method is the TC polygon method. The area for each station is gathered from Google Earth Pro, and the precipitation is gathered from the government website, and then we times the area with precipitation. Then we apply the formula polygon area for each station times precipitation over total polygon area, so that we can get the average precipitation is 6.56 millimeter. For the last method, isoheater method, the isoheater intervals data is gathered from the functions supplied by the Google Earth Pro to determine the height of the chosen region, and then the average precipitation is gathered from the isoheater interval, and then the area, and average precipitation times area. Formula is applied to get the data of average precipitation, polygon area for each isoheater intervals times average precipitation over total polygon area, so that we can get the value is 8.5 millimeter. After determining the water level, area, perimeter, hydraulic radius, velocity, and the total flow, now we can use the data we had calculated, insert to the hydrograph. For base flow, we need to apply one method called straight line method. We use straight line method to obtain the data of base flow so that we can get the data of direct flow. As we can see in the chart, below the line of orange color, the region is called base flow. For unit hydrograph, firstly, we need to determine the total runoff volume. We use the sum of direct flow times 3600 seconds to get the value of total runoff volume. Then we use the data and then apply to the formula of runoff depth, which is total runoff volume over catchment area to get the data of runoff depth. And then the UH ordinate can be determined by using the formula direct flow over runoff depth. After getting the data of UH ordinate, so that we can plot the unit hydrograph, and the calculation details is shown in the project of our group.
My name is Muhammad Hafiz. Now I will explain about rational method. Rational method is to estimate peak runoff rainfall event based on catchment area information. Regarding from information from Google Earth Pro, our group can identify the length. The value for the length is 17,640 and the slip surface is 0.3%. Based on the information from Google Earth Pro, we can calculate the value for T naught. Okay, for the value for T naught is 122.90. After we get the value for T naught, we can calculate the average rainfall intensity. The formula for average rainfall intensity is lambda times T power of K over D plus theta power of N. So the value for average rainfall intensity is 66.24 mm per hour.
Okay, next we go to the cross-section profile, which is we will use for the end. We will use the natural stream channel, which is 0.03. Okay, next is the cross-section for upstream Sungai Rasau Tunggul Keris. From this cross-section, we can get the perimeter of the cross-section is 63.919. For the area, we get 123.6. The slope is 3.4%. For N is 0.03. For R is 1.96. And the last one is the discharge. Using the main equation, we can get the 11898. Next is the cross section for the middle stream Sungai Rasau Tunggul Keris. Okay, if you can see this the cross section of the middle stream. So from the cross section we get the meter. For the middle stream we get the perimeter is 78.04. For the area is 177.44. For the slope is 1%. For n is 0.03, and for the r 2.27. And for the discharge using the Manning equation is 10.0216. For the last but not least, for the cross section, is a downstream Sungai Rasau to Keris. Okay, from the, if you can see from the Google Earth, downstream you can get the perimeter of the downstream is 108.26, and for the area we get the 316. For the slope again you get the 4.3, and is 0.03, and then for r 2.92, and for the q is, which is the distance using the Manning equation, we get the 44622.64.
Next, we go to the chapter 5, which is discussion. Flood are a growing problem in Malaysia, especially during the non-monsoon season from November to March. This is due to human activity that have caused change in the hydrological system, such as rapid urbanization, deforestation, and construction on hill slope. Flood risks have increased significantly over the past few decades, putting community at risk. We conduct a project to collect data on water level and rainfall pattern in the study area. Our data collection has since spent 31 days, during which we obtained water level measurement from a specialized station. We analyzed the data to uncover trends and patterns, which help us calculate mean area rainfall, peak flow, and river flow rate. Our analysis identified several key insights and trends related to water level and rainfall pattern in the study area. By combining these three methods, we could calculate the average precipitation accurately. This data will be used in the next stage of our project to determine the river peak flow and flow rate. According to the data, the average precipitation is 6.905 mm for the arithmetic mean method, 6.56 mm for the Tyson polygon method, and 8.5 mm for the isohyper method. Additionally, we determined the flow rate for the selection cross-section, which were 11898, 10216, and 44622.64. Furthermore, we were able to calculate the peak flow at the catchment boundary, which were found to be 22245.55 using the Manning method. Unlike the rational method we had initially considered, we opted for this method which is appropriate for largest area. However, rational method is only suitable for a catchment area below 60 hectare, which is 0.8 km. The calculated peak flow was 499.01 when we used the rational method. So, the rational method is not suitable for this project since the catchment area is 67.8 km, which is exceeds the suitable range of the rational method. And last, we go to the last part, which is conclusion. In conclusion, it is important to take preventive measures to reduce the risk of flooding in areas like Selangor, Malaysia. This can be achieved through measures like building flood wall, implementing early warning system, and relocating people from high-risk area to safer allocation. It is also crucial to raise public awareness and educate people about flood risk and emergency preparedness, as well as water conservation practice. Restoring and preserving natural water retention features such as forests and meadows can also help reduce peak flow and prevent downstream flooding. Additionally, improving urban planning by preserving natural drainage pattern and avoiding construction in flood-prone areas can minimize the risk of flooding and ensure community safety.